Good afternoon, everyone. Welcome to the Raise.dev's Hacktoberfest Help Desk. My name is Joe, and I am not your host for this evening. I will be getting out of the way very shortly to leave you with our founder, John Britton. But just before that, I want to tell you a little bit about what's going on here today, what the Hacktoberfest Help Desk is, and how you can get help from us in the future. So first up, if you have any questions during this Hacktoberfest period, Hacktoberfest being a celebration of open source put on by our wonderful friends at DigitalOcean, you can ask them to the Raise.dev Hacktoberfest Help Desk at Raise.dev Hacktoberfest. We will. I'm already having my green screen's causing problems with my forehead. We will, once you submit those questions, we'll be able to help you. You can, we'll match them with our guests, and we'll find guests who have expertise in the topic you need help with. We'll email you to let you know which show we're going to solve those questions on, and we'll send you a recording after the show. So you can get all of your questions answered by submitting them to the Raise.dev Hacktoberfest Help Desk. You can find a video on our Twitch channel. If you go to like our profile videos, there's a highlight of me filling out this form so you know how to submit questions. This is the last stream of this week. Over the weekend, we'll be updating the schedule on our Twitch page, twitch.tv RaiseDev schedule. That'll be updated with all the wonderful folks coming up next week. I'll do a little teaser for you end of the show. We'll have a look at the schedule for next week. But one thing to note, whilst that schedule doesn't have the names that are on next week, the time slots are accurate. So if you want to find out when we're streaming, you can go to Twitch TV RaiseDev's schedule. So we have a very special show today. As I said, John is hosting. You may have seen John in our streams last week, and we have a special guest who will be introduced very shortly. And we're doing another dive into old code. I'll let them tell you all about it. So I will add John and our special guest to the stage. Hi, John. That's not John. It's not Chris. It's a struggle. There we go. Too many buttons. Over to you, folks. Have a wonderful stream.
All right. Thanks, Joe. Hi, everybody. My name is John Britton. I'm the founder of Raise.dev, and I have a special guest with us today, Chris Hunt, who is also a coach, a software developer coach with Raise.dev. He's an awesome developer. I'm really excited to spend some time with him today. But if you wouldn't mind, Chris, would you just introduce yourself pretty briefly and just give us an idea of what kind of a developer are you and your background?
Yeah. What kind of developer am I? If I had to summarize myself,
it's a tough question, right?
If I had to summarize myself in 3 words, it'd be Ruby on Rails, I think.
All right, cool.
I've been working with Ruby on Rails for 11 years now, and yeah, I just keep sticking with it. Every company I join is using Ruby on Rails. I love the framework for my side projects as well, and it's just what I love working on, APIs and backend stuff.
So how did you end up in the crowd of people using Ruby on Rails? I know that 10 years ago it was very, very hip. It's maybe not as hip these days. But like, how did you get caught onto that train?
Well, I wasn't. So I went to school. I took like a traditional route. I went to college, got a CS degree, and didn't even know Ruby existed by the time I graduated. Just wasn't even on my radar. Never heard of it. We used Java almost the entire time throughout our curriculum. And then I got my first job as a Java developer, and wanting to like ramp up my skills more, I'm listening to a bunch of podcasts. At the time, it was Ruby Rogues. That podcast may still exist. I'm not sure. I think it's like a network of podcasts now. I think, right? It's like there's multiple versions. Anyway, so I used to listen. I don't listen to it anymore, but I used to listen to it quite a bit, and some other Ruby podcasts. And yeah, everybody just sounded like they love using it. So I started playing with it with some side projects, one of which we're going to look at today. During that progression, eventually at that same job that I started with Java, I was able to get one of our projects to start up working with Ruby on Rails. So I was working at a Department of Defense contracting company at the time, and the way that works is it's like working like as a regular contractor. The government has like things they want people to build, and so you write up a document on like how you're going to build it, what technology you're going to use, things like that. And so I said, hey, Ruby on Rails would be a great fit for this project we're working on, and yeah, I just never really looked back.
Okay, great. So you were saying that you got into like a bunch of the podcasts. Did you ever watch the Railscasts series?
Oh yeah, every single one of them.
When I was getting into being a developer, that was like one of the things that I watched like all the time.
But I never used TextMate. Not even once.
So what's your editor? What's your editor of choice?
Vim, and that's something I was introduced to in college, and I also have stuck with that ever since. So I like to think that I'm constantly taking in additional pieces of information to assess whether I want to switch editors or switch languages or switch frameworks. But like,
Yeah.
man, I love them. I love Vim.
Yeah.
I love Ruby. I love Rails.
Well,
They're so powerful.
I love hearing about favorite tools, and every developer has their own favorite tools. So we'll get into some of that as we're going through. I'm sure you'll have some shortcuts, some commands, some things that are interesting that we can always we can learn from. I want to go back to your CS degree because you mentioned that you did Java in school.
Yeah.
I wonder, what's your opinion on like the relevance of a CS degree to a career in software development?
I think it's not relevant at all, to be honest. I think
Okay.
that I think that it's like, I'm glad that I did it. I think that it's useful. I think college is useful in many ways, but not for, I have this debate with Louisa, my wife, quite a bit because she's a teacher. So I think that I think college is very valuable in many ways. Like, it taught me how to live on my own and how to just do stuff on my own and try all these weird things that I probably wouldn't have been introduced to, one being Java otherwise.
Yeah.
But in terms of the companies I've worked at, and like, I interview at the companies I work at now, and we don't even look at the resumes. It's seen as bias. So it's not. I think having the skills is important. I think how you get the skills isn't really that important. So some people excel, I think, in those environments, like the going to a classroom every day and listening to lecture and taking notes and stuff like that. But that doesn't work for everybody. It didn't work for me. It actually took me an extra year and a half to graduate because I sucked so much at school. But I had like hobbies I was doing. But I think it's valuable for some. I don't think it's necessary in any way to do it as a profession.
So if you were to advise a new developer who's getting into the field, and they kind of have the option of college, what would you advise somebody who's just saying, like, I want to be a software developer, what should I do? Like, what's kind of a good like first step for them?
So like I said, I found college very valuable, but not necessarily to learn how to program. I found it valuable just as a human, like how to cook food and live on my own. So
I know a lot of developers who have degrees in all sorts of different things. I know there's actually like a very high correlation of programmers to people who are like very far into the arts, like music or other kinds of like artistic pursuits,
and philosophy as well. I've crossed paths with so many philosopher majors.
Yeah.
So I would say that they're not necessarily related. I would say if you're excited to go get a CS degree or go to college, I would say absolutely do it, especially if you don't have to take out a big loan to do it. If it is something that you're like dreading and you absolutely want to get out of school as quickly as possible, I would say it's not necessary and don't do it. So I don't see them necessarily as related. They're just kind of like two different things.
And then for the folks in the audience who have already either decided to skip college or maybe they completed a degree and they started a career and now they're transitioning into software, what kind of advice do you have for them about getting the skills that they need for becoming a software developer?
So what worked really well for me is I'm sure you have other hobbies, other things you're interested in. Build apps for those because it's for one, it's fun, right? It's like it's fun to build a thing that helps you do your other hobbies. So like I've had hobbies like related to the Rubik's Cube, and right now it's indoor cycling, and I've built apps for that. And I used to be a photographer. I've built lots of different types of photography apps. And so if you could find ways to build an app to help your hobby, I think that's a really great way to learn. It's like a real use case. There's probably like hundreds, if not thousands, of other people that would love to use it right away, no matter how good or bad it is, just because it exists. So yeah, I think that's what I would say. I'd say pick a hobby that you really like. Think of something that you don't like about it. Like, you wish that you could take these two apps that already exist and merge them together somehow, or you wish you could automate this task of it or something, and then write an app that does that thing and then tell people about it. And then, it's very satisfying to see your analytics go up as people are using it and see people sign up and have a good time. And then, you'll learn a ton in the process. And as more people come on, you'll have to deal with like little scaling issues that you didn't think about. So, database queries that might need to be optimized a little bit, or views that take forever to load, that kind of stuff.
Another thing that I like about the build an app for your hobby is that you tend to be a domain expert in your hobby. If you have like hobbies that you're really passionate about. And one of the things about being a programmer for me is that you hear this thing all the time. It shouldn't be that hard. We could get it done in like a couple hours or something. And like inevitably it's way more complex because the domain isn't clear, right? You have to like really define what you're trying to build and all the different kind of moving parts. And I think building something for a domain that you're already an expert in is much easier because you can think about and reason about that domain a lot better than if you go after a space that you're totally unfamiliar with, from the start.
Yeah, you are the customer, right? It's the perfect relationship. You're literally writing it and testing it and giving yourself feedback, so it's perfect. There's been companies I've worked at, like we've worked at GitHub, and GitHub is one of those companies where I felt so connected to the product because I used it every day before joining GitHub. I used it every day while I was at GitHub, and I continue to use it every day after leaving GitHub. So it just makes the project so much more fun to work on.
For sure. So I would assume that baseball is a hobby of yours, given that we're going to be talking about an app related to that. So maybe you can just give us a little bit of a briefing on, what is this app that we're looking at, and why did you build it?
Sure. So contrary to what it might appear to be, I actually don't like sports that much. But this, let me give a breakdown of this. So the app we're going to be looking at today, I wrote and used 10 years ago and haven't done anything with it since. It's Ruby on Rails. And this started from my first job after college. So I talked about my first programming job, but my first actual job out of college, I was a photographer. And I shot weddings, I shot engagements, and then eventually started shooting news. In college, I was the photo editor for the newspaper, so I moved into shooting news and then eventually sports. And so I shot nothing but sports. And I lived in Seattle at the time, and I would shoot all the pro sports teams, the Sonics, the NFL team, the Seahawks. I would shoot the Mariners, the MLS team, the Sounders, the soccer team. And so one of the issues that I had doing this, it sounds like a very fun and easy job, but the problem is after each quarter, you need to submit photos because it's like you're racing the people next to you on the field taking the exact same photo you're taking. There's like a little box that you can stand in while you're taking pictures. So everybody's getting the same photos. So at the end of the quarter one or quarter two, you need to download these photos as quickly as possible. You need to write very detailed captions that say, if you got two people running into each other, you need to say who the person on the left is, what team they're on, their position, maybe a little history about them. And then you need to do the same for the person on the right. You can't get any of that wrong. Can't get their number wrong, their position. You can't misspell their name. You can't get the team wrong, anything like that. So I wrote this application called Roster Runner, and it used to live on rosterrunner.com. The domain has since expired. I got tired of paying for it. And what it allows you to do is download all of the rosters for any of the pro sports teams from their website. And there was two sources I used to grab that data. There's no APIs that existed for this at the time. So I was literally scraping the ESPN website and I was scraping the MLS website. And it would download the team rosters because they're not static. They change every game, they change. And so you'll download that roster, it parses it out, and then it generates keyboard shortcuts that you can import into something like Text Expander or Alfred or any of the other, vast number of tools that do let you type. For example, if I wanted to, do you have the README by chance available?
Yeah, it's up on my screen. Yeah, here we go.
Okay, perfect. Yeah, if you scroll down to the bottom there, so that's what it looks like. But and we can look at that in a moment. But if you scroll down the bottom, here's a good example of what it's going to generate. So while I'm writing captions, I can type S6. And S stands for the team, so that's going to be Seahawks, and 6 is going to be their jersey number, and it'll expand to Seattle Seahawks quarterback Charlie, and I can't read it on the screen. I think it says Whitehurst, 6. And then there's a bunch of other snippets for getting the first name or the last name or just their position or just their team, et cetera, et cetera, et cetera. And then at the very bottom, there's a special one there, that S6S, which you could use to generate tags. And these are tags that the wire services require. This is the format they require so that when they ingest your photos, they get tagged appropriately and sent out to the people who care about them. So the application just generates these keyboard shortcuts and it makes it so I can write captions quicker and send them off. So
excellent.
That's the gist of it.
So you got into this not because of your love of sports, but because of your love of photography.
Yes, exactly.
Okay, great. And I also I heard a story. I mean, this is before you're obviously using digital cameras and whatnot, but I actually heard a story. I had a friend quite a while ago who got to go to the Super Bowl to be a film runner.
Oh,
And so
sure,
what they
yeah.
literally would do is they'd like stand next to the the photographers, and like when the film was done, they'd like run in a pouch up to the thing and like go and hand it in. It's kind of crazy.
They still do that. Just with memory,
Okay.
They do it with memory cards now.
With memory
And
cards, okay,
They'll
yeah.
run it up to the laptop, and there'll be someone up there writing the captions and firing them off during the game while the photographer is still down taking photos.
Okay, so we know the motivation for this app. What technology did you use, and how did you come to the conclusion to use this technology?
So my general strategy for choosing technologies is choose the thing that I am the strongest at using, unless I have a reason otherwise to try something else. So either the reason is like React is a great example. I avoided using React for the longest time, but I have started working at so many different places and working on so many different projects that use React that I now feel like, okay, I have to get really good at this technology. So now I'm starting to use it more. So that would be an example of a reason why I would use something new. So with this, I had been using Rails for exactly, I don't know, 6 months at this point.
Yep.
So in the arc of my development journey, which is very small, this is like something I'm pretty familiar with. So yeah, I just decided it made sense. I did want it to live on the web, and I wanted it to, so I can use it in at any stadium or anything like that, and regenerate the rosters at any time. So yeah, I went with Ruby on Rails. The database I'd love to talk about, because that was a really poor choice. But
okay, we'll talk about that in a sec. One of the things that I like about your philosophy of choose the thing that you know the best. So I recently we're in early access for Raise.dev, and we had to build some stuff, and it's very tempting to go after the newest shiniest technology and build a whatever it is rendered on the back end, like pre-built React components, so that when the page loads, the components are already rendered, and then you use a React front end with an API and all this stuff. And it's yeah, that's great if you're super well versed in that. But if you just need to get the job done, using the tools isn't a bad thing, right? And so again, I'm a Ruby developer as well. We basically just decided let's just use Rails to build our app. It's the thing I know the best. It's the thing that we know it works. It's stable. It has the necessary features, and it might not be the latest and greatest of everything, but the overhead of having to learn how every single thing in the new technology in the framework works is not always worth it. And I think your case of React makes a lot of sense, though, in that it's reached a general acceptance that it's kind of the thing that people do now, to where it's you shouldn't keep your head in the sand and just not learn new things. It's just
it's actually
a trade-off.
And because I've waited so long, it's easy to use now. Use React with Rails is I added it to an existing project in an hour and had all my views over, and so yeah, not being that early adopter and just waiting till the tooling is set up. I mean, it's definitely fun to do that. When I started doing the Rails thing, I felt like it was kind of an early adopter thing, but it definitely has its cons too. It's nice just to wait until everybody else has decided it's a good thing and there's a bunch of tooling around it and it's easy to use.
I think for side projects, it makes sense. You might want to try a new technology and give it a shot and see what it's all about and learn and see what things. This is something that I think is really cool about trying new things is you see their patterns, and you can take patterns from those back to your main development language, your main development framework. And so when you have a deadline and a product you have to ship in a set amount of time, the added risk of learning an entirely new tech stack in order to ship it is just too high in some cases. So I like your logic there. So maybe we can talk about kind of the overall architecture of this application. And so I help a lot of people with code interviews, and not that this is necessarily a job interview, but I think that there's a lot that can be taken out of this kind of a conversation that's helpful with interviews. And what I do as a hiring manager for engineers is, rather than giving somebody a whiteboarding challenge or a coding thing that they have to do and submit a coding exercise, what I usually like to do is I like to ask the candidates to provide a project that they've worked on in the past that's either open source or something they can share with me. If it's closed source, they can just share it to me only, and walk me through it and talk to me about it, so I can ask them questions that are relevant to their experience. Rather than me asking them trivia, I can ask them about things that they should know because they were writing code about it. So I kind of want to treat this conversation a little bit like that kind of an interaction where, I might ask you about like how something works or why it works that way. And it's okay if you don't know, but I'd love to like kind of go in deep when we can. But I always start those conversations with like a general structure and organization question around, how is this app organized? And as a new developer coming into the project, how can I find my way around?
Okay, yeah, good question. I too had to go through this process an hour ago because I haven't looked at this in a while. But this is another benefit.
It says like 10 years over here.
Yeah, yeah, exactly. It's been a while. It's still open source too, so anyone can feel free to update it from Rails 3 to Rails 6 if you want. So
yeah, that's a hell of an upgrade.
So I would say to describe the general structure, I would say this is another benefit of using Rails in that the structure is pretty much the same as any current Rails project with a few exceptions. And the one I noticed right off the bat was the test directories are a little different. But besides that, this is a typical Rails structure. So there's going to be a test directory that contains all your tests, and those are usually broken down in a Rails project today. It's going to have like your models, and it's going to have your controllers, and maybe you'll have some other folders that you add like acceptance tests, which are like full integration tests or something. The way that this is broken down is functional, performance, and unit, I believe, right? So it's a different directory structure. I know I didn't name those myself because if you actually click through, you'll notice that the tests are almost entirely empty. So
great.
So this is a red flag right away when looking at a project. The test is horrible. So this is where the tests are contained. Usually you can run on any Rails project. You can run the test just by typing rake. Test is going to be the default task, and you might need to do some database setup before that. But as you may notice in this project as well, if you go back to the root of it here and click through to look at our database config. So I believe that's going to be so it's going to be, I think it's config.
DB.
Yeah, config DB. Yeah.
Yeah, database YAML.
Yeah. So Rails 3, I don't actually think it's like this anymore. I think you can create a Rails app today using whatever database you want in the creation process. But back when you made Rails 3, whenever you create a new Rails app, it would always default to SQLite 3, which is what we see here. It's just a file store database that you can check into a repository if you wanted, something like that. It's easy to use. In fact, you don't have to have any databases running. It's just a file on your computer. But the downside is the performance is pretty bad. But as you can see here, I decided to just use SQLite 3 and not only development and test, but also in production. So that was a very strange choice, but it seemed to work fine, I guess.
Yeah.
So
I want to talk a little bit about the database. So
sure.
Okay, so when we're talking about web application architecture, it's pretty common to have a web server, which is a process running on some machine that runs your code and processes requests. You have inbound requests. Those requests are HTTP requests. They get routed to a particular controller, and then they are executed, and a response is returned to the browser, which renders your web page. All of the user data is typically stored in a database, and there's a connection between that web process and the database. That connection, it can be local, it can be on the same machine, or it can be over the network on a separate machine. Usually, if it's over the network, it's going to be a machine in the same physical location, so it will be a very fast network connection. It's not like you're using a dial-up modem to connect to your database or something like that. But then the application runs queries against the database and pulls in kind of data. Now, I want to talk about what's the difference between SQLite a little bit more, and what the alternative is, and what you would typically be using in production. So maybe you can kind of share a little bit about your idea of like how databases work and like what the main differences are here.
Sure. So yeah, I'm continuing to learn about databases. This is unprompted, but look at the book that's literally on my desk that I'm reading. So it's called Designing Data Intensive Applications. So this is constantly something I'm trying to learn because it's hard and I don't know all these things. Right now I'm learning about ClickHouse, which is kind of an amazing database if no one's heard of it. Okay, so with like Rails, what most applications are going to use today, especially a new app that's just starting, is probably going to use Postgres. And there's a couple reasons for that. Postgres is it's designed in a way that just works well with the default Rails conventions. It's a relational database. So all your data is kind of related to each other. So for example, in this app where we're keeping track of teams, we have several sports and they have many leagues. And then those leagues have many teams, and then those teams have many players, and those are all tables that are in the database, and they all link back to each other. So Postgres is a great relational database, and for most people, it'll work fantastic. It's the default on a lot of platforms like Heroku and DigitalOcean just created a new app platform as well, and they provide Postgres right out of the box too. So it's a great default. If you don't know anything about databases, I would usually just default to that. Once you start having like a very specific problems, then then I would usually start looking into a different database. So if I was writing like a web analytics website that's just collecting massive amounts of data that I'm probably never going to modify. I'm literally just recording visits to a website. So it's like it's static data, but constantly coming in, probably billions of records a day, but immutable. I'm never going to write any updates. There are other databases that are much better at handling that type of data and allowing us to run queries across that. So though, as far as how Postgres works, it's like you described, it's network based. So it's not if you go to the end of the line, it is eventually a bunch of files sitting on your disk, but the way that you're communicating with it is through a network connection. You have a address that you're usually an IP address or other kind of network address. You have a socket. You have a username and a password that you're logging in, and that gives you certain things that you can do on the database, so you can protect certain parts of it from your application or run multiple applications on the same database.
One of the really big benefits to having a database that you're connecting to over the network is that you can scale your web processes horizontally. So like the idea that if you make a really popular application, so say this roster runner got really popular, unfortunately, you're going to have a lot of database contention. Whereas with doing it with Postgres or something else, you can have many processes of web servers that are handling requests, all connecting simultaneously over the network to one database. And the database is going to be able to handle like a multi-threaded kind of processing of those queries. Whereas the file system-based version of SQLite actually can only be open at one time. Like it can only have one supported connection at a time because it's using your operating system's file open method, right? So like basically somewhere in the Ruby code, in the Ruby interpreter, there's a library that like connects to SQLite, and there's some C code in there that says like F open, right? And that's what's actually opening the file handler, and that's blocking it from being accessed from other processes, I believe, right?
Yeah, and like I said, like I assume Postgres, if you follow the pipe long enough, eventually you will see the same F open on Postgres. But the nice thing is there's so many layers in between that can cache things and distribute it, so you're not shoving everything down the same pipe. You're able to. Postgres probably assumes that eventually either you're going to stop writing data, but it also has this idea of a transaction, which is to say like here's one fixed thing that we want to write to the database. So. Yeah, it's at the end of the day, they're very similar, but Postgres has a lot of stuff in the middle that just like scales way better than just writing a file on your disk.
So this brings us to a really popular topic in software development, which is abstraction. And what I like about the way that this is set up and the way that you're able to use like your SQLite database or Postgres is they both use SQL, right? That's an abstraction. It's just a language that lets you mess with databases. You can create tables, you can insert rows into tables. And Postgres and SQLite use the same SQL for the most part. The broad things, like some of them have more specific features that are not cross-compatible, but broadly it's SQL. And you can your app doesn't have to speak Postgres or SQLite or MySQL or Microsoft SQL Server or whatever. It has to speak SQL. And then SQL can run on multiple different backends. And so we're like abstracting that. And the thing that you said about like at the bottom of the chain, if you go through Postgres, at the very end there's an F open and it's writing things to disk at the end of the day as well. But we don't have to think about that because we're using this really awesome abstraction concept. And I think that's going to come up over and over and over again. In your entire like software journey as you're getting into this. Like abstraction is like one of the most important concepts that you can learn about. So we don't spend the entire time talking about databases. We're going back to the structure of this app. So you've got your database stuff set up. What else is important about the organization and structure of this application?
Sure. So I talked about, when we were talking about database, about some of the different tables that are in here, and which we also just saw in the schema. So this is like all the data that we have in our application. This is, like I said, this is for downloading different sports, which could be like football, soccer, basketball, things like that. Each of those has multiple leagues. So there might be, with like the case of NCAA basketball, there's a men's division, a women's division. That's what we're considering a league here. And then each of those has many different teams. So University of Washington might be a team, for example, and then each team has many different players. And so each of those has little bits of information that we're trying to save. In this case, it's mostly just the data we need for those text expansions. So it's going to be their name, their number, and their position.
Okay.
So that's the data we're storing, and then the way that we like comb through that in Rails is using what Rails calls its models. And so if we look in our models directory, we're going to see those 4 things we just talked about: player, sport, team, league. Those are all connected to those database tables. They can write the data, pull the data out, and then you can also add a whole bunch of extra behavior in there. And as you see, if you open literally any of these, some of those methods are quite long and can probably be cleaned up quite a bit. But I guess this is a good example of somebody's first Rails app here.
I like this case statement, and it's just like nested case statements.
Yeah, yeah,
beautiful.
Yeah, very beautiful.
Okay, so I think we'll come back into these models and let you dig us through the code in a little bit. But what else is important in the organization here?
Okay, so we have our database, we have our models. That's how we're getting reading and writing our data. The way that we interact with that through our application is through our So if I go to rosterrunner.com, what that's going to do is it's going to look up that route. So there's a routes file in here, which is in Rails 3 is a config routes, I think. Yep. So this lists all the different routes that our application responds to, all the different URLs we can go to.
Before we move on, what is a route actually? So this is something like I've helped a lot of developers get into this stuff, and it's amazing how a concept that's so fundamental gets glossed over all the time. And so what is a route, and how do we you're saying that like this is where we set up the routes, but what is a route and how does it work?
Sure. Yeah, it's like it's kind of like how it sounds. It's a route into your application. It's a path into your application. And with HTTP, which is what a web app uses, that route is composed of the address, which is the URL. It's the place where the route lives, and then the action that you can take. And each of those can be distinct. So you can have like, if I go load up rosterrunner.com in my web browser, and I just type rosterrunner.com and press enter. Well, right now it's not going to do anything because the domain is expired. But let's say it's active, right? It's going to, the web browser is going to do a GET request to rosterrunner.com, which is just the root URL, which in Rails is called the root. And then in this file, this routes file, we're telling Rails what we want it to do when that route is hit. So we're saying when someone says get on the root URL, we want to do this thing. And in Rails, how you describe a thing is you're saying, I want it to go into this controller and call this action. And a controller is just a Ruby file with a bunch of methods in it, and an action is just the name of one of those methods. And it could be anything you want it to be. So in this case, the convention for Rails is if you're going to a root URL and you're wanting to load up all of the things, in this case I'm wanting to load up all of the leagues, that will be calling the index action. I want to get the index of all the leagues. I could call this anything I want. I could say league all. I could call the all action. I could call the whatever action. You could name it whatever you want. But the Rails convention is to use index if you want to fetch everything.
Yeah, list. Yep.
And then just to add on to that, there's other verbs that you can use. So get is one. You could also do like a put. You could do a post. You could do a delete. These things all are mapped differently in the routes file, and you can just trigger and do different things when that happens.
So this is the different HTTP verbs is something I want to talk about a little bit. When I was getting started as a software engineer, one of the tech companies that I applied to was Twilio. And they're an API company. And an interview question I remember very, very vividly from there was, what's the difference between a get and a post in HTTP? And so this is something that, the the wrong answer is, a post is used for submitting a form or something like that, right? Like it's about how it's used, not necessarily like what the actual difference is. But the idea in HTTP is this kind of semantic use of requests with a resource. So in HTTP, the idea is that you have a resource. Let's call it a player. So in here, you can see on line 9, you have resources players. You have players as a resource in your application. What this means is that there's some URL at your application. So let's call it like example.com/players/1. And that is the URI that identifies a resource player with the ID 1. Now, with that URI, you can do multiple actions. You can get the player, which means give me the data from the player and display it. You can delete the player, which would mean remove the player from the database or remove the player from the app. You could put the player, which is kind of like an update in place, like change the name of the player, change their jersey number, whatever. You could post to the player's resource. So you could go, example.com/players post, which would create a new player, right? So what's interesting, though, is each of these verbs has a different semantic meaning, even though they're all on the same URL. And so when you're using your browser, generally you're sending GET requests. If you submit a form in your browser to like create a new object or like post some form data, you might submit the form with a post and your browser will send a post request. And then on the server side, the route might be the same and it will do different behavior based off of that verb. So just like thinking about HTTP spec and the different actions, the general actions are get, put, post, delete. Any other one? There's like 7 or there's like patch. There's a couple other ones that are like more esoteric, but the most common are like CRUD, create, read, update, and delete. So that corresponds to post, put, get, and delete, right? So anyways, just aside on that. So, okay, we've got your routes here. We know what routes are. Routes are the directions to get to the right code from your requests. And then let's see, what else? So we talked about tests. We talked about the database. We talked about your routes. Let's go into this app folder. And so this is something that's like core to the way that Ruby on Rails works, is the kind of design pattern that's not unique to Ruby on Rails, but it's used in many different applications, model view controller. And so maybe you can tell us about the model view controller pattern and why Rails uses that and what benefits you get from it.
Sure. Well, they kind of all have, they all do different things. So the models is kind of, you can think of it as like our data layer. That's where we're getting stuff out of our database or whatever other sources that we have for our data. We have usually in our models, maybe if we're integrating with an API somewhere, we might have an API client that we're using. Anything that gathers data or just like reformats data or just has the data, right? The controllers are what we just talked about. They're kind of like routing requests. So they'll be able to take requests that have been routed to them using that routes file that we looked at and dispatch them to collect data from the models or show a certain view or something like that. They're like the traffic controllers. And then the views are what we actually see in the browser, or if we're using an API, it's that JSON that comes back in the response. It's literally our view into the app. It's the thing that we're seeing. So they're separated not only, I think, for the behavior part, but also just because you kind of work with them in different ways. So like the view is usually going to be some kind of display language. Like in a browser, you're going to be using HTML, CSS, JavaScript, that kind of stuff that your browser understands. Whereas the model layer, you might be using, in this case, you'll be using Ruby, maybe you'll be using SQL, maybe you'll be using, like I said, like a client, API client library, something like that. And then the controller is in the best case, literally just routing requests and collecting things and taking data from this source and then shoving them into this view and showing it to you, that kind of stuff.
I think I definitely want to talk about what a controller's job is in more detail, because there's definitely different opinions on this, and there are some best practices about removing code from your controllers and code reuse and stuff that we can get into. But I wanted to talk about the data flow in the model view controller as well. So one of the big things with abstraction is there's also like what's dependent on what. And in MVC, when you're doing model view controller kind of architecture, what is dependent on what, and what are we trying to reduce dependencies? Where are we trying to reduce dependencies, and why? So like we could just have, like, when I first got started as a web developer, I used PHP.
Mm-hmm.
And if you're not familiar with PHP, PHP is great for making a really, really quick web app. You make a file, you add .php on the end of it, you write some HTML, and then whenever you want to write code that does something, you just put a special tag, and then you stick your PHP in there, and it's magic. You make a dynamic web page.
So it's like JavaScript.
yeah, okay. But like, the downside to this is that when you start to manage, a bigger app, it becomes like spaghetti. There's like, everything is everywhere. If you change one thing, 15 other things break. So MVC, you can actually nowadays, like, there's, it's not even that new. What's it? Not Zen. CodeIgniter is like the PHP framework. There's like an MVC framework for PHP. There's probably other ones too that I'm not as familiar with. I think Cake PHP was another one.
Isn't Laravel one? Or is that
probably? Yeah, I've heard of that. I don't know what it is, but
PHP is making a comeback. I just got to say it. I mean, I don't use it myself.
Facebook is PHP, right? So
Laravel. That's the one I keep hearing about. There's a convention. It's very popular.
Yeah. So, I mean, this is the thing, like, don't dig on tools, but like there is a right way and a wrong way to, or a good way and a bad way to build things. And so MVC is a pattern you can use in pretty much any language that will help you avoid these kinds of pitfalls. And so maybe you can talk a little bit about how that, what your opinions on that are, and like how dependency and how you should think about that as a developer getting into MVC.
Sure. Yeah. I think that MVC just kind of helps you separate things. It gives you separate. It kind of makes you think about putting things in different buckets. But in my opinion, it should be even more separated, right? Like even in your model, for example. So Rails, usually what a model is it's something that is a subclass of active record. So in many Rails applications, what people mean by a model is a table in my database.
Yep.
But you can actually create, hundreds of other models that have nothing to do with your database, and they're just behavior that your other models use that still live in that directory. So I think in almost all cases, if you could bundle up a piece of behavior into a smaller piece, that's usually a good thing. I mean, I guess there are some cases where maybe I can't think of one, unless you just don't like having lots of files, but there's so many benefits to this. And one good example is, to go back to the active record example. If you look at this application does not have a user model, but if you look at an application that has a user model, typically everything is hanging off the user, and the user file itself is thousands of lines long. Especially as the application grows, it just keeps, like, the user has everything, right? They do everything. Yeah. So the file is huge. The problem with that is because that file is so tied to the database, and all the behavior in there like assumes access to these attributes that are being pulled right from the database. It's really hard to test when you don't have a database. And so the more that you can pull stuff out and put it in its own file and test it on its own. So if I could take this big chunk of this big method that's inside user, and I could pull it out into a more descriptive class that describes what it's doing and has parameters that it needs to do its thing, then I can test that without a database even running. And it's way faster, and I can test all these different edge cases and pass in all these weird inputs. Whereas if I left everything in the same file and gave it access to the world, it's really hard to test. It's really hard to like fix little bugs. It's really hard to prove that it's working correctly. Things are just easier. You also have the benefit of being able to use it in multiple places. So, if you launch an application with a user model and it becomes successful, eventually you're probably going to have a team model as well, because that's just how it happens, right? You create this service, you're like, oh, I got all these people signing up. Now this company wants to sign up. So now I need like a company or a team. And so now a team has many users. And next thing you know, your team model has to do the same stuff the user has to do, right? So, so if you had extracted a lot of that behavior, you could mix it into both of these. It's already well tested on its own over here. You don't need to test it 3 different times, and you just know it works, and you have, it's nice and fast, and when you fix a bug in one place, it fixes it in everywhere else that uses it. So I think the model view controller is a nice way to kind of guide you to break up your code automatically, but it's always best to break it up even more if you can.
So I think we've got a good overview of the structure of this code. We looked at it on GitHub. In the chat, there's the URL if you want to go and check out this code yourself and look around. If you have questions about the code that you see and you want to ask, just put them in the chat as well. But Chris, what I think we should do now is maybe we can actually start looking at some of the code in detail. And I think best for you to do that as the driver.
Sure. So now you can see my screen. There we are, little terminal window. So I've pulled this down. I guess so. It's been 10 years since I looked at this, so I can go through my process that I usually use when exploring a project, I guess, and we can talk about some stuff. So something I like to do when I first start is like try to figure out what Ruby version this is expecting me to use. So today that would be in a
RVM,
if this was a new, it might be like it depends. There's
Ruby
Ruby
version.
Yeah, there's a bunch of different files you can use to manage a Ruby version. This isn't the case with this one. So I think this is using what is okay? So this is RVM. Yeah, back in the day of RVM. It's an older Ruby version manager. So when I was working on this, I was using Ruby 1.9.2. which unfortunately hasn't been supported for many years, and I couldn't get it to build on my Linux box that we're looking at right here. So we can't run the app, but we can explore it more, I suppose. So another thing that I like to look at is the gem file, and this just gives me kind of like an idea of what's going on in here, what like requirements it has, maybe what it connects to, whatever, just like a high level of all the stuff that it's importing. So when I look at this, one of the things that stands out to me and would make it even harder for me to use right now is I don't have versions specified for these things. So, we have this Haml and Sass, both probably don't exist anymore. Thin, which is a web server, jQuery, which is an older JavaScript library. And what I wish was on these lines is what we have up here, which is this little, I think it's called a tiddlywaka or something. This little squiggly arrow.
I think it's called. I don't know what the symbol is called, but it's the pessimistic version.
Okay.
Right. Like.
Yeah. It's the
behavior
of it.
Any non-breaking version, right?
Yeah. What we're saying here is we're gonna allow somebody to use any version of Rails that is a bug fix version of 3.0. So I can upgrade to the latest version of 3.0.x. But I will never be able to automatically update to 3.1, which with versioning could be a breaking change, right? So usually with a minor version change like the 1 or the 2 or the 3 here, it's going to be breaking. It's going to be adding some features or removing some functionality that you might be used to. So anyways, I wish that was on all of these gems because that makes it a lot easier to update the app because then I can just
can you not look in your gemfile.lock?
I can, but now I have to do that. Now I'd have to go.
This is actually an interesting thing because I actually have a preference when I'm writing my gem files to not specify versions in my gem file unless it's required, unless I have a specific need. Because your gemfile.lock version will keep you locked unless you upgrade it on purpose. No.
Yes. Okay. So. That's true.
Because this is actually this is something that I'm not sure about. I would love to know more.
Let me share my philosophy on this. So yes, this is the gem file. It lists all the gems that your application uses, and when you type bundle, it's going to install them. There's another file, gemfile.lock, that is generated. Hold on, I made a change to this file somewhere. There's this other file, gemfile.lock, that is generated when you run that command that saves all the versions that you happen to install at the time that you ran it. So if the current version of Haml was 1.8 when I ran bundle, then this is now going, let's see what actual version we have. Okay, so this is saying that when we ran the bundle command, we installed Haml 3.1.1, okay? And it's got this for every single gem. The downside of that is when it comes time, when Haml releases a new version, say Haml, because there's always bugs they're fixing, or maybe now it's compatible with Ruby 2, because it's not right now. I can't run this app on Ruby 2. I can only run it on Ruby 1.9, and I can't compile that, right? So in order to run this on Ruby 2, I have to update my gems. But the problem is, if I just run bundle update to update my gems, it's going to update Haml to version whatever the heck it is today. If it's at version 5, it's going to go all the way to version 5, and that's going to probably break all of my views. Haml is a language for writing your views. So that's why I prefer to have these. It's not one or the other. They're both very useful. So the lock file will make sure that when you run just bundle, Your environment
the
is set
same
up the
version.
way that's intended. And when you deploy it, you'll use the same gems in deployment. The advantage of the little tiddlywaka here, the pessimistic operator, is that when you run bundle update, you'll be able to update to the latest version of your gems that don't break anything. And if you don't, otherwise I can never run bundle update because I just don't know what's going to happen.
Yep, makes sense.
So we could fix this. We could go through our gem file and look at the version of Haml we have, and then we can add the little thingy here, and then run bundle up. That probably still isn't going to work, right? Just because this is so old. But in general, if you're keeping an app up to date, that helps.
So how about these gems that you have installed? What gems are we looking at? We got Haml and Sass. Those are for styling. SQLite we talked about already. What's Thin?
Thin is a web server.
Okay, so Thin's an old Ruby web server.
Yep.
Better than WebRick, but not much, I would assume.
Yeah, it's better. It was better than the default WebRick. Will paginate. This is a gem that does easy pagination. So when you get a bunch of results, say we got 100 players on our team, it'll easily do the queries for us to paginate that into smaller pieces so we can click through page numbers.
And then you have this console group down below. I've actually not used I've used like group test, group development, but I've never used group console before. What does that do?
So I can tell you what it does, but I'm not sure if this even exists anymore. But if you run Rails console, I wrote B is short for bundle exec Rails console. So if I type this, it's going to open up a Rails console, which is just IRB. And in this environment that I'm in now, it's going to load up all the gems that I've specified. So this is going to show, these are like, these gems here, I haven't used them since I made this project, but what I think they are is like pretty formatting. So it'll add like color to your IRB output and stuff. So if you have like a hash and you inspect it, it'll have like, integers will be red and strings will be blue or whatever. I have no idea what this is. This is probably something else that makes things. I really like things.
It's clearly it makes things fancy.
Yeah, these are all. These are all to make the console pretty. I assume. Yeah. Development. This is another group that only loads when you're running Rails in the development environment. So these are gems that are probably useful with debugging or things. This looks like it's for generating something, views or models or something like that.
Probably has something to do with like Rails G, and then when you do like scaffolding or whatnot, right?
Yeah, and this is for, I had the app deployed on Heroku, which is an app hosting service, and that everyone's probably familiar with. And back when I wrote this app, they actually released their executable as a gem file. It wasn't installed any other way. So this lets you run the Heroku command and deploy and do things like that. And then down. Usually I would just delete this now. I don't know why that's in there. I'm also noticing
it was probably some of the template stuff that you just
it was right. Yeah, that was very scary to remove. But like now I delete. Now I would delete it. I also am pretty OCD about quotations now, so I would probably change that to a single quote like I just did there. Yeah. I would probably also. There's really not a reason to separate these things really, in my opinion, anymore. So I would probably just group all of this together nowadays. I would throw this in I would throw SQLite 3 in the garbage as well.
So this gives us an idea of some of the stuff that's installed. So so now we have an idea of kind of like what the environment, like obviously we can't run it because you couldn't get that version of Ruby going, but what else is there to look at in here?
Sure. Then the next thing I would look at is and I'll touch on this briefly since we already looked at it, but that would be the schema here.
Yep.
So this gives me kind of an idea of the data in our application, what we're working with. So we already went through all of this, but just some comments here on some changes that are like big red flags to me right now. I would most certainly, unless I had a really good reason, have every single one of these columns have a not null constraint on here, because as you'll see if you were to go look at this project on GitHub, almost everywhere I'm checking for nils all over the place. And the reason for that is because our schema allows you to put nils in the database. And this is all of this data is stuff I want to exist. I never want to create a league without a name. I never want to create a league without we can get into this too. This is completely changed in sports now. I never want to create a league with numbers, without a number, without a position. So like I would add a not null constraint on all of these. I would also probably add some unique constraints. So I would want like all my leagues to have unique names. I would want all my players probably to have unique
So
positions.
you're talking about database constraints. So this is something that probably SQLite may or may not implement all these kinds of constraints. I don't actually know, but definitely Postgres would.
Yep.
But what's the trade-off of doing a constraint? So you can add a constraint to your database, which basically makes it impossible to insert a row into your database that doesn't fit the constraint, versus using something in your model that just validates that the model is the way it is. Like, for example, you can have a validation that says every name has to be unique. And that's different than a database constraint that says the name has to be unique or not null or so on and so forth. So I know you're suggesting like you put a not null constraint on all of these. What's the benefit to doing that versus using a not null validation in your models?
I would do it everywhere. So the benefit, I would say if somebody said I can only put validations in one place, I would put them on the database. And the reason for that is just because that's our data, right? That's where we want to protect that, because if that gets messed up, then it messes everything up. So if we accidentally start allowing people to create players with no name, now our code has to handle that case. Whereas if we can make the assumption that there's always going to be a name, then our code is like way cleaner, right? Because we don't need to constantly be checking if there is a name. So as long as we can protect that data, then it's just easier to work with our data. If we know what state it's in, we don't need to check. Oh, is it a string? Is it a number? Is it empty? Is it missing completely? Those are all things that code we don't have to write. Adding it in the other layers is still useful though, even though it's not necessary. Even if we don't add a model validation, or if we're making a form, we don't add like a JavaScript validation, we're still not gonna be able to write that in our database, right? Because we've added the constraint. But the reason we add those other ones is because it just makes things nicer. So if we add the validation to our model as well, so if I say in here, I want to make sure that my first name and my last name are always present, and then in my model I add the same validation, I can then return like a pretty error message. If somebody tries to create a player without a name, I could say, hey, all players need both a first and last name, please. Instead of raising an exception and then trying to guess what caused that exception. I can create a nice error message, and then we can create it again in, like I said before, in the JavaScript as well. So you could have some validations in like 3 different places. Just to make it like a better interface. So when you're filling out a form, maybe it turns red if you've spelled something the wrong way, or if you're missing it or something like that. But at an absolute minimum, definitely do it in the database. If it's only
so, what else would you change about this database schema? Anything else?
I would add default values for some of these. This is something I thought about when I started looking at the code earlier today too. So there are a league in the context of this application is something like NCAA basketball. And for a league, there are different divisions, and there are like a men's division and a women's division. So all throughout the code, I have this concept of like female URI, male URI. So team has a gender associated with it. So for one, these terms aren't even used the same way they were used 10 years ago, right? But the other is I would completely remove these, because it doesn't make sense for a league to have like a female URI and a male URI. This is like basically this would be the URL on ESPN that contains the roster for this league. I would probably just have one URI and just have the leagues have different names. So this would be like, this would be like whatever the name of the league is. It's like women's NCAA basketball or whatever. And not even, just completely remove that part of the code, because it adds so many weird things in here. And once we dig into the code, there's lots of switches on it and stuff.
Yeah,
so
it's probably like you're going to have one object that you're passing, and then you have to do like 2 cases for each object, when it would just be easier that every league itself would be its own instance of an object.
Exactly, yeah, because they are different leagues. So I would probably just remove that completely. What are some other changes on here? Like I said, default values. I'd add not null on probably all of these.
How about indexes?
Yeah, index. So the ID of the column is not even listed in this schema, but that would be indexed. I would index other things in here too, though, things I wanted to search on probably.
Yep.
So things like the league name, I'd probably add like a unique index on here, which basically says that we can't create two leagues with the same name, and it makes it so that if we're looking for a specific league, it'll be very fast.
So first of all, the ID is not listed here. Does that mean that these tables don't have IDs, or is that just like a Rails thing that the ID is just not listed?
I don't know. I assume so. Obviously,
because I think in modern
IDs.
schemas you'll see the ID. At least like I'm using like UUIDs instead of integer IDs in my apps, and so like in our schema it's listed as like a string column. But yeah, I don't know.
Yeah, so
I guess
different
create
Rails
table just has it by default, right?
This is a different Rails project here. This is a more modern one I'm working on. Let me see.
Yeah, no, I guess create table must just do it automatically.
Yeah. I think it just creates it automatically.
You'll also notice that in those create tables in the newer app, there's no created at and updated at. I don't think I saw that in there. Like those might also be like by default automatic. Oh no, they're in there. They're in created at and updated at. I see them. Okay. I don't know. Okay. Anyways,
notice all the null constraints on here.
Yeah, right. Today I learned make sure your data is like really constrained and you know what you're going to expect. The other thing I want to talk about is the index. So we said we might add indexes to some of these things, and like what is an index and why do you want to add one?
So my mental model of an index is just like the table of contents of a book. So if I have a encyclopedia and I want to look something up, if I'm going to flip through the entire encyclopedia looking for the topic, it'll take me probably forever. I might even give up, which some databases will do if you do a search that's big enough. Or I could look at the table of contents, and the table of contents is only 3 or 4 pages. And so whatever I put in that table of contents is going to be way faster for me to look up. And that's kind of what an index is. So if we stick something in the index, we're essentially sticking it in the table of contents, and it makes it a lot faster to query by that attribute. So if we have, 100 million leagues in our database, and we want to find one that has a specific name, if we don't have an index, that could take a very long time. If we do have an index, it'll be quite a bit faster in most databases.
So generally when it comes to, computing problems, you're making a trade-off between 3 things: time, memory, and like CPU capacity. Like there's like a trade-off, right? One of the things that I think about with an index is you're basically trading disk space for time. So when you have no index, when you insert a row into your table, it's super, super fast because it doesn't matter where it goes. It just goes on the end, right? It's not in any particular order. You just stick it at the end of the thing. And now when you go to search for it, you have to search through every item in the list to find it, right? When you have an index, what happens is on insert, you need to spend more time inserting than you do when you insert by just appending to the end. So there's this whole concept of where in the data set should it go? And you might have to move other data around. I mean, if you did like an algorithms or data structures course, you probably implemented like a linked list and you want to insert an item at a certain point, and sometimes there's no space there. So you have to make new links and move things around. But on insert, it's like slightly slower to insert, but then on lookup, it's much, much faster. But you're also giving up disk space because you have to store the index, right? The index is small, but you are giving up some disk space. So you're basically making a trade-off on those
adding
a
page to the table of contents.
Exactly, right? If you add a page to the table of contents, okay, it takes a page, but like it saves you everything in time.
Yeah,
right? So it's totally worth it. But that is the trade-off I think that you're making there. Okay, cool. So what else after the schema? So we've got some more stuff we can look at.
Sure. So I could go into there's a bunch of different places we can go from here. I can either pull up a specific model, or we can look at a rake task that might be interesting. So
I'll give you an idea. Feel free to go a different route. But when I request the homepage of this app, what happens? And like, can we kind of walk through the code flow?
Oh, sure, yeah. So we'll go back to our routes. So this is gonna tell us what happens when you hit a certain URL. So if you go to the homepage, that's called the root in Rails. So in this case, it's saying the root goes to our leagues controller and our index action. So we need to look at the league's controller, and we need to look at the index action. So that's this right here. So this is what's going to happen. So let's dive into this code a little bit. I'm going to add a space here. So the first thing we're going to do is we're going to grab all leagues in our database. Oh, no, we're just grabbing one league. So we're grabbing the first league in our database that is not custom. So let me explain what custom is.
There's a lot in this line that we can go into. So
so first off, I would use a scope for this, which we could talk about later. But this is the idea of custom is, as I said, all these leagues, sports, teams, players, they're all scraped from the ESPN website. Those are not custom. Those are just like scraped or whatever. Oftentimes when you go to a game, like if you go to like a Seahawks game and you go into the press booth, they hand you a piece of paper that is today's roster. It's not online yet. It's just a piece of paper. And so there's also in this application another mechanism for adding teams and leagues and players, and that is through a CSV, comma separated file. And when they're generated that way, they're called custom. So that's what this is. This is just grabbing all the teams that have been scraped, or it's grabbing the first league that has been scraped. And if that league exists, so if there are any leagues in our database that are not custom, then it will redirect to that league. So if we've downloaded an NFL team at any time somewhere and it's sitting in our database, it'll show that team, the first one of those. If we don't have that league, then I suppose it's going to render the index action, which might actually blow up. I'm not sure. But let's say this is successful. We have some team. So it's going to grab our league out of our database and it's going to redirect to that league. What it means in Rails when you say redirect to a model, that means it's going to show that model. So what it's actually going to do is it's going to call this down here. It's going to call show league. And so we can kind of step through and see what this is going to do.
Before we go through show league, let's go. There's some things in the index action that I want to go through. So why does that variable league have an @ symbol in front of it, and what does that signify in the MVC architecture for Rails?
Sure. So this is it's an instance variable, and so in Ruby, when you create an object, which this is an object called leagues controller, you can store data on that object and you can store that as instance variables. And now this variable is available everywhere inside this object. If I create another method here called foo, I could call index, and now I have a variable called league because I created it up here that I can use. In the context of Rails, there's a little extra feature that you get out of this too. Any instance variables that I assign are automatically passed down to the view. So if I pull a league out of the database and save it to an instance variable called league, then that means in my view, I can use that variable. So real quickly, if we go to like league show, you'll notice that I'm using a league variable here. It's not declared anywhere in this file, but we're able to use league because it was created in the controller here.
Excellent. Yeah. With the MVC pattern, right? We got model view controller. Something that I try to emphasize with people is that the controller is kind of like at the top of the hierarchy. The controller understands that there is a view, and the controller understands that there is a model, and you'll often put your business logic in the controller, right? So there might be model-specific code, like a league might have like ways to get certain data from the league. You might have methods that go and like fetch it from ESPN and parse it and save it in the database, and all that logic might live in the league model because that's code related to the model. But in the controller, the controller has a league, like it might go fetch a league or whatever, and then pass it over to the view. The controller knows about leagues. So there's a dependency from the leagues controller to the league model. Like the leagues controller has to know about leagues. And then there's a dependency from the leagues controller to the view. That is that the view must send data, or the controller must send data to the view. But there's no dependency from the view back to the controller or from the view back to the model. We should be putting only display logic in our views. And so, we can use these instance variables to effectively say, like, instead of calling that league, what we could do is, for example, we could have league name as an instance variable. We could put a string in there. We could have league membership count. We could put some value in there. And then we're basically just passing pure data down to the view. And then the view can just access all those instance variables and display them without needing to know that there's a model called league. In practice, we often will pass models down anyways. Another pattern that I've seen and I adopt in my Rails apps is the idea of using something called a view model, which is basically creating a class. That class understands the model that it's presenting, but it also only exposes an interface to the view that is very, very small. And that way you're only passing one instance over to the view. The other thing I want to ask you about is this where method. So a really, really interesting and like super powerful feature of Rails is active record or AREL. And I want to talk about like the where method, what it does, what it returns, and why it makes Rails so powerful.
Sure.
Yeah.
I love where.
It's
and
like
all of
probably
it's,
it's probably the most important and valuable method in Rails.
It's also slightly evil because what it does is it's writing SQL for you. And so if you're not familiar with SQL, then it'll mean that you'll never understand SQL if you only use the active record interface to it. But it also does a lot of cool stuff for you automatically, escaping and just cleaning up your input and making it safer. So in that way, it's powerful. So this, for example, like we'd have to write a pretty regular but long SQL statement that would grab us.
Can we try like roughly writing that SQL statement?
Yeah. So in this case, it'd be like select star from leagues. That's going to be the name of the table. Hold on. Let me. Oops. Leagues where is custom so it would be something, I don't know if there's quotes on one of these or whatever, but that's pretty much what it is. So this is saying we want all our columns we want all the columns for any leagues where the is custom field is set to false, and we only want one. So limit one. And Rails is probably also sticking this in here as well.
Yeah, ordered by ID or something. Created
it's
probably ID.
Yeah, it's probably ID. Yeah, so Rails is probably also putting this in here as well, and you can change all of these types of defaults. So we're basically taking this and generating this without having to write this, which is nice because we'd be writing this a lot. There's a lot of SQL that we use in Rails, and so
this is like a fairly simple query too. It's like,
and there's like literally every line in this can have some typo that would be hard to catch. But the nice thing is the Rails is going to tell us if we do something wrong. Another example is, let's say we wanted to find where the name is equal to something. Foo. We're looking for all leagues whose name is, or we're looking for the first name first league whose name is Foo, right?
Yep.
We would do that. We could do that a number of ways. We could probably fill in the same way here. We could do like name equals and then do Foo. We could also use a kind of a nicer syntax. So we could say where name is equal to Foo, which just kind of reads a little better. I mean, would definitely be my preferred. The only reason I would start using this syntax if I wanted to do like a like query or something, so like a fuzzy search. But usually, most queries you can actually just pass in a hash of your key and your value that you're looking for. And this does more than just shove it into the SQL. This is going to do things like, let's say we have a form that has a text box on it, and the user is able to type whatever they want. My fancy name, my fancy league, and they've submitted this value in our form. And well, but I was going to put params in there, but let's just say we're pulling this out of our params, and now we're going to pass that in, and we're going to find that team, right? This is great. This will work. If we were doing this in SQL and we put it down here, it might look something like this. So let's say this is a string and we're interpreting what they've typed in, and we do form value. This will also work. Both of these look great. The advantage of using this, though, is Ruby is doing a lot of cool stuff for us. For example, if the person on our form was doing something like some kind of weird closing this off and then like drop table or drop database, whatever this is called, roster, runner, production, etc. Right? I would be taking that and shoving it into the SQL statement, and they would drop my database. But the nice thing about using the Rails helpers is they're aware that people do this or that we might do this accidentally, and this will be cleaned up. So all of this stuff will be escaped, however it needs to be escaped, and we don't need to worry about
SQL injection attack, right?
Yep, exactly. So it protects us from that kind of stupid stuff. It'll do some type checking on there too, like if it's a different type than what we have in our database. So yeah, it just protects you from a lot of stuff and looks pretty.
So that where is going to generate a query for when you call first, it'll generate a query, execute the query, and then it will, your SQL database, whatever it is going to return back a string. League is not going to be a string. So what's it going to give you in that league instance variable?
Yeah, so that goes back to our league model that we have here. So this is this is when we say leagues.find, this is the model we're talking to here. It extends this active record base. This is what gives us all those helpful functions like where and where not and select and other things. When we pull that record out of the database, which is just a bunch of data, it's going to create a new instance of this class league, and it's going to populate all those instance variables that we talked about, which is in the schema, right? So it's going to populate name, created at, updated at, short name, is custom, all that stuff with the whatever the value was in the row. And then now we have this model that we're passing into the view where we have not only those pieces of data that came from the database, but we have these extra functions that we can, or methods that we can call here on that object as well.
Excellent. All right. So we've got our model, and then we say redirect to league if the league is set. If it's not set, then I would assume that this shows the index view. If there's an index view, it would render the index view. So is there an index view?
There is an index view. Hey, look, we're currently updating our rosters. Feel free to generate a custom roster while you wait. How nice.
Awesome. Yeah, that's a very nice friendly error message.
Yep.
There's no data available. And then, but if there is a league, it redirects you to the league. So
yes.
Let's see.
So that is this method here. So it's going to redirect us to show that league.
So here's what you're saying right now. It's like already a case state, like a split in your logic because of this multiple kind of URLs thing.
Yeah. So because I'm differentiating on whether it's a men's or women's team, I'm having to do these like all over the place. These like checks. See, and here I'm including the check here. I've included the check here. So this is where we could have thrown it away if each league just had a unique name, right? So it looks like we're pulling out the gender param and providing a default if it's not, which is male, which is potentially offensive. We have our search. This is a search bar that's on the website. So this is when you're searching for a particular league, whatever that query is will get passed in here. This is the actual league here that looks like we're getting it again. So we're going to find the league, and then we're going to redirect to the league page, and we're going to pull it out of the database one more time.
Yes. So when you do that redirect, that's actually going to be a response to the browser. So I like to talk about controllers as being responsible for handling requests, right? So the request comes from the browser for the index page. The server will respond with a 203 redirect, right, or whatever it is, a 301. I don't know what the status code is. Anyway, it says go somewhere else, and then your browser says okay and makes another request for the show path for that particular league. So then we could potentially be in a separate process at this point, because if you have multiple processes or multiple threads, a different thread will be handling the request. You could have handled other requests in between when they got to the index method or the index action and the show action. So there's not a guarantee. Like we don't have the league anymore. We have to fetch it again. So we're fetching it out of the params that the user passed back. Okay.
Yeah, and then it looks like we're taking whatever that search term is, We're searching for it. I guess that search term is going to be a team. So we're passing that search into our team. Here's a great example where the cleaning up our parameters is useful because it looks like we're passing that in. Although this is probably a method we wrote. This isn't an active record thing. So now we're searching for our teams. We're grabbing the team that's in the same league. We're ordering it by the alphabetical name. And then here we're using that paginate gem that we saw earlier. We're going to serve up 10 teams at a time per page. And then down here, it looks like we're setting the cache headers as well. So if somebody
refreshes the page
loads
again.
this page again, if their browser cares about this header, then it won't make a new request to our website.
Can we look at the team model and look at that search method and see what it's doing?
Yeah.
Okay, so where's this? Oh, there it is right there. So it's a class method. So you've defined it on self. And then what are we doing here?
Looks like we're just taking in whatever the search term is. And this is like a fantastic example of the SQL injection, right? So we're taking whatever the search term is that was passed in, and we're sticking it in the where clause. And this is doing but notice we're using the where helper, right? We're not using string interpretation here. We're using the question mark.
Oh, it looked like for a second it looked like it was string interpolation. I didn't see the comma there. Yeah,
no, it's being passed in, so it will be cleansed by Rails hands.
10 years ago, you did the right thing.
Yes. I suppose I might still do this a different way, but so we take. So we're doing a case insensitive search. So we're taking the name, we're uppercasing it, and we're doing a light query. So it's basically a fuzzy search. We're saying if the name contains what we've searched for.
Yep. That's what those percent signs mean. Yep.
Yep. And then otherwise, we'll just not do anything. So scope.
So you're using using the built-in full text search of SQLite, which is probably incredibly fast.
yeah, very fast.
Okay, cool. Otherwise,
with Postgres, it's probably fast, but yeah, SQLite's probably terrible.
What does that scope do there?
Scope just returns a scoped. It returns a scoped query. It returns an empty query essentially at this point. It's just something that you can keep tagging queries onto.
So this goes to method chaining, which is like one of the really cool features about the way that Active Record works with where. When you call the where method, or you call any default scope or a named scope or a custom scope or anything like that, Active Record, your instance, because it inherited all these like behaviors from Active Record, will return a specific type of object. And that object is not the results from the database, right? That object is, I guess in modern terms, it would be an Active Record relation. I don't know if like this version of Rails, it was still called, I don't know if it had been split out, because I know that over time, Rails has gotten more and more modular with like Active Record relation versus active model versus active record. And like, I don't know where in the timeline this is, but it's effectively giving you an object that represents the query that you want to make to the database, but it hasn't made the query yet.
Yeah, the query might just be like select star from teams, might be what it is at this point. And then we're just kind of appending things to it. Yeah, so I mean,
so the reason you have to return a scope there is so that you can continue to call additional.
Yeah, so here we're tagging on a where, and then we're tagging on an order, and then we're tagging on a paginate.
Cool.
So if we didn't return a scope there, we wouldn't be able to continue this.
So great, we have our first
of millions of dots.
First response from the app. We're pretty far into this, and we've made it to the point where like you go to the homepage and you can see the app, and you can see it. You can see a listing of whatever the first league in the database is. But what I want to know is how does this stuff, the data about the leagues, get into the database? You said that you're scraping all kinds of things. So
yeah,
do you scrape on demand? Like if somebody requests a page, do you go scrape it, or like do you do that in a background job, or what?
Yeah, this is a wonderful part of the app that I would do completely differently today. So this is the rake task that I was talking about. So this app has rake tasks that you kick off whenever you want to refresh the teams. And these descriptions are a pretty good description of what they're doing. So we have one that rescrapes all of the different sports and leagues, one that's just for MLS, one that's just for MLB, for example. And what it's doing is it's literally like if we look at this, so let's look at league.scrape for a second. It's going to go through and destroy everything in the database.
Mm-hmm. Oh, wow. Yep.
Rescrape all the teams and puts out some statements, I guess, in the process. So
yep.
This is how it gets built. These get kicked off. So like in Heroku, you can kick off a rake task just by running like Heroku run rake scrape MLS, right?
I also remember in some of my apps, I used to do this thing where like Heroku has a cron scheduler.
Yeah.
So you could like, instead of paying for a background worker, you could just schedule a cron job that would run a rake task every so often. Yeah.
Yeah, or just restart your app. That was something
restart the dyno.
I used to restart my Rails app once a day automatically just because of the memory. Heroku now does it. So side note, Heroku does that automatically now in Rails apps. I was looking at an app recently and I noticed the memory consumption was like staying pretty good. And I'm like, dude, this is amazing. And I realized that Heroku is automatically restarting the app every day.
Yeah.
It's pretty funny. Okay, so this is how stuff's getting scraped. Running rake tasks manually. It's scraping ESPN, MLS website, creating the new records. So I wouldn't even use rake for this kind of thing today. I would probably have my own, depending on the like how I wanted to share this with people. I might have like an admin interface or something on the app, or that's probably how I would do it. I wouldn't want any random person kicking off updates
Scraping
with
tasks,
something this expensive. But I would probably just be using something like Sidekick, which is a job processor. And I would create a whole bunch of different jobs. I'd create a refresh leagues job that kicks off a bunch of refresh teams jobs, that kicks off refresh players jobs, and just like a whole bunch of individual jobs.
What are the benefits of doing this in jobs versus what you're doing here? When you do this here, does this run serially, or what's the?
Yeah, there's a bunch of benefits. With a rake task, you don't necessarily have to worry about like locking up your application per se. If you've got with SQLite maybe you do, but this is out of the like request response cycle. So if you go to Heroku and run this, it's probably you're going to run this on a different worker. So your web app's still going to be responding and things like that. So that's not the bad side of it. I would say the bad side is like, for one, I need to manually open up a console and run this rake task. That's a pain in the butt. I'd rather have a button that I can click to do it, right? So that's one con. Another con is what if ESPN is down, or like the ESPN website has like changed their formatting or something? It's like
you started by deleting everything in your database.
Yeah, my database is now wiped. And ESPN is down, and I just see an error message in my console output. There's not much I can do. So the benefit of having a job, especially with using it with something like Sidekick, which is like super robust and easy to use, is if something like that happens, you can handle all those errors. And if ESPN goes down, Sidekick will retry, but it'll do what's called exponential decay. So it'll retry and then retry again, and then wait a little longer and retry again, and then retry again, and then it just keeps getting longer and longer and longer until eventually it's just going to wait till tomorrow. And it's like, okay, I've tried 10 times, ESPN still isn't responding. We're just going to wait. We're going to give some time instead of DDoSing their website. We're gonna wait till tomorrow to do this. So, and all that happens without you having to do any kind of like manual intervention.
So there's a couple of questions in the chat about multi-threadedness and different processes. And so I want to take a second to talk about, let's talk about the process that's running when you're running your Rails app, and what a worker is, and how they relate to each other, and how they communicate with each other. I don't think it's that common. I mean, Ruby does have threading, but I don't think it's that common for people to use threads in their Ruby web applications. But maybe you can talk a little bit about that, and then I can add some architectural improvements to what we were talking about as well that I think we could do.
Sure. So let me look at the question.
So the question was,
I've created some Ruby and Rails
apps, but I don't have a clear understanding of processes or threads. How should I be? What should I be careful about them? How can I start learning about those? And then the follow-up from the same person was, worker is another thing that I don't understand. What is this? What is a worker in relation to processes and threads?
Okay, so a worker isn't necessarily like a specific thing. In terms of, I think Heroku has this concept of a worker. Sidekick, which is a job processor, has this idea of a worker, and these are like separate processes that run and can do whatever you want them to do. So, in the case of job processing, I guess is a good example here. So if I want to scrape the ESPN website and do it in a background job, that's going to happen if I use Sidekick. It's going to happen in a different process, in a different thread. And the way that we're communicating with Sidekick for that to happen is by using another database called Redis. So if I want to send something over to this other worker that's doing stuff for me, I create, in the case of Sidekick, I'll create this thing. Sidekick refers to these as workers. They can also be called job processors, or I think there's active job now as well in Rails, which is the same thing. You can use that with Sidekick. I'll create a version of that has all the behavior I want that job to do. So I want it to go out to ESPN, create some records, etc. The way that I send that request over to Sidekick is I take the information that it needs to start that job and I put it in Redis. And then there's a bunch of workers running over here in this separate process at their own speed, doing their own work. And they're just pulling things off of the Redis queue as they come in and doing the work. So they're pulling off whatever you've put in there, which is usually like an active record ID or maybe some other pieces of information. They're pulling off those little bits that you put in there. They're creating an instance of that Ruby worker class in their own environment, their own process. They're creating an instance of that. They're executing the code that you've written in there, and then they're just pulling off the next job and doing the same thing. So it's all running by itself. You can turn off your Rails app once you've dispatched a job, and it's still going to run. It's its own worker. It's its own process.
Yeah, I think something else to just keep in mind with regards to the question of like what's a process, what's a thread. So on your operating system, you have a process manager that is basically context switching. So say you have a one-core CPU, it's giving each process a little bit of time on the CPU to do a thing. Modern computers, we have multi-core CPUs. We're able to do more than one thing at the same time. But the context switching is still happening because you're generally running more distinct processes on one computer than you have cores. Generally that's what's happening. In the case of a Rails application is one process. You run Rails server and it boots a process, and that process runs and it receives requests and it sends responses. Now, in production, what you end up having is you might have a web server in front of the Rails process, something like Nginx or Unicorn or any web server that's a very high performant, multi-threaded, multi-process, high throughput web server that can receive lots of requests, and then it will route those requests through to your various, Rails processes that take the request and then, use your database and build a page and respond with it. And it can, effectively say, I can handle lots of requests in parallel. If there aren't enough Ruby processes running in the background, I'll hold on to them and I'll just make them wait until the next Ruby process becomes available, and then I'll pass the request through to them. It'll do the work and it'll pass it back. But generally, you can think about your Rails app as like one process. In production, it might be many processes with like something in front of it with a ton of threads to make everything work in parallel. Because a lot of what we do is wait for network in web. So you might think about it as if you have a user who's on like a 56K dial-up modem, and they connect directly to your Ruby process, your Rails server process. They're blocking up that process from doing anything from any other user while they're downloading the data. When you have a web server in front of it that's like basically proxying it through, your Rails app can respond with the whole response, give it to the web server, and then the web server can, like, in a multi-threaded fashion, be non-blocking and be much faster. So there's this whole kind of like process architecture. Now, when it comes to this process or this job of adding all this data into the database, a couple of things I would suggest here is, one is all this scraping code should be moved into a service object of some sort, right? Like you were talking before about in Rails, when people say model, they're often referring to like an active record subclass, which is something that's tied to a database. And like, that's a really basic understanding that I see a lot of early career devs using Rails do. But actually, when it comes to object-oriented programming, we can model things that aren't actually in our database. So for example, you could create a model of a sign up service, right? And that sign up service is a object in object-oriented programming terms that is a model that handles all of the behavior of a user signing up, right? And similarly, you could make a service for, you know, scraping a team or scraping a particular source of teams or a particular source of rosters. And so you have like one instance or one class that you could pass a parameter like ESPN.com, this URL, I want to fetch all the people on the roster and create them. And then each individual page that you're scraping might be a separate instance or a separate call to that service object. And now you can create a very encapsulated thing whose job is, given some input, the name of the team and the destination, like ESPN, it can scrape all the data. And that's totally independent of the idea of doing things in parallel or queuing jobs or retrying when something fails, if there's downtime. That's all the responsibility of a different class, which you would say is the job class in this idea of like doing a background job. There's a common refrain among programmers, the single responsibility principle, right? You want to give each object in your system one specific job, and if there's a different thing for it to do, make a different class. So anyways, extracting that out into a service object means that within your Rails server process, which is running all the time, you could call that service object and it would run inline, or you could create a new process. And in that new process, you could load the same class and run it. And because both processes are connecting to the same Postgres database, those two processes can have side effects that impact the entire greater system. So it's not like, if you're thinking of it in a programmer like mindset of like, I wrote some code and I've got two processes running. How do I make this other process over here aware of what changed? Well, because they're both running off of the same database, it's kind of no extra work for you. It just happens. So that's like, I think should help a little bit with like the processes separation. Like, what is a separate process? Generally in Rails, you're talking about running your server. You've got one process, unless you're doing something fancy in production. When it comes to the idea of a worker is just a name for a process that has a particular job. I would say, like, you could have a worker that is processing background jobs. You could have like a cron job processor or something. So I think that there's an endless kind of rabbit hole to go down with this stuff, but kind of broadly, that's the idea. Okay, so we've got a way to scrape all this data, get into the database. We've got a way to view it. Are there any other major features in this application besides scraping the data from ESPN and putting it in the database, and then looking at it on the web? I mean, I guess there's the text expander part, right?
Yeah,
like, there's like
probably the only other component, I think.
All right, so let's like briefly take a little look at that, and then we'll wrap it up. But like we want to see how this is actually useful. So you're basically going out and you're scraping a bunch of data from somewhere. You're allowing users to come in and request that data, but you need to format it in a nice certain way so that they can update their text expander or whatnot.
Yeah, so let's find that. I think that's what this is. Yeah. So this is horrible, right? That's what my gut tells me. This is absolutely horrible. Well, the number one reason why it's horrible is because I wrote it and I still can't understand it, right? I also see lots of like signs that this is an early Ruby project. I'm using I all over the place. I'm not using Ruby's like enumerables for things. This is, it's common in Java to create like variables and increment them and decrement them and use that for counting and going up and down. But with, Ruby, we have lots of super cool enumerables that we can use. I'm not using any of those.
So this is the idea of idiomatic Ruby, right? Like if you showed this to a Ruby developer, they would be like, "This is not a Ruby developer who wrote this."
Dude, they would freak out. This would be.
So can you tell me what is an enumerable, And like what would be like, maybe you could just write like a little sample of like what this would look like to loop over this stuff with an enumerator.
Yeah, of course. So let's figure out what this is doing. So this is starting with I equals 0. It's going until we've reached all of our players, it looks like. And here's where we're doing our increment. So we're starting at 0 and we're going +1 every time.
And then you're accessing players sub I, right?
Yep. And then we're doing players I plus while I plus, and then we got a separate loop here. Players I plus 1 dot number. I plus 1 is players and players I plus 1 dot number. So this just looks like removing duplicates. I guess I have a comment there, right? Gather all the players with the same number. Ah, I see what's going on here. So there's this, I saw, and I only know this because I saw this in the README. There are some teams that where multiple players have the same numbers. And so because one might be first string or second string, or I don't know what the reason is, but it definitely is true. And so this is gathering up all the players that have the same number, it looks like, and storing them in this thing called a group, which is an array, it looks like, which contains usually just one player, but sometimes many.
I see. Okay.
And then we go through the group, and this is where we're generating all these different expansions.
Oh, there's a lot in this loop.
This is huge. This is huge. This
huge
is the
loop.
guts. This is
Okay,
this is a prime example of like where extracting it would be immensely beneficial, because there's a lot going on here. There's a lot of testing that needs to be done here. This is not tested as far as I know. We're reading a lot of this stuff from the database, which makes it even harder to test. So being able to like pull this out and pass this stuff in, and you know, like players, for example, this is being read from the database. This isn't something we passed in. So just passing all this stuff in would make it a lot easier to test and understand, I think.
Yep. So this is in the team model.
Yep.
And so what might we do? Oh, so there's two things we want to do here. One is, how can we write this loop a little bit more idiomatic Ruby style? And then how could we improve it to make it more readable? So the first thing that I think we should do is just, let's assume we don't care what the logic in the loop is, and let's just like iterate through the list of players, right? How would we do that with like idiomatic Ruby, and what what happens?
Yeah, sure. So we're not needing to collect the players in any way. So we do players.each, and this will pass in a player to our block, and that removes this. If we did still need the index, we can also stick on a with index and pass that in as well. And now I is like the same as it's always been. It's going to start at 0 and it's going to keep going up. So from this point on, the code might actually continue to still work, because we're using I and we're incrementing it. When we get back to the top of this loop, though, I is going to reset, so it's probably still going to break. But let's not use I. And everywhere that we have players, I is going to be player now because we've pulled it out. I don't know what to do with this block here. I'd have to
players
think about
I
that.
plus 1.
I'd have to think about that. I'd have to think about that more. But the I plus 1 goes away. It looks. I think that's the only time that we're using it. Yeah.
Yeah. So mostly I wanted to get at the point of Ruby has this thing that's really common, the iterator, and kind of how you use it. So for people who aren't that familiar, like how would you parse this players.each do player? Like what's the method call that's happening here, and what are the arguments? And how would this compare to like JavaScript, right? Like what would be a similar thing that, if you're familiar with JavaScript, this would be?
Yeah, so so JavaScript and Ruby both have these like closures, right? They behave a little differently, but in Ruby it's called a block. So what this is doing is it's just like our I loop. So if I can write this out, I guess we just had it out, but I guess I can write it out a little simpler. So it's while I is less than players.size -1, I plus equals 1, block.call, block block equals begin. Players I puts player. So it's kind of like this. We're by calling dot each, it's doing the same thing here. It's iterating through all of our players. And then for each of those players, it's executing this entire block of code.
Yeah.
And passing in the player to that block. So it's kind of like this. It's taking the current player right here, players.i, calling the block and passing it as a parameter. And then we have that available as a variable that we can do stuff with. Yeah. So that's why we do players.each to player. And then here we have a player variable because that's what we've called it up here. And we can do whatever we want with that inside of our block.
This code is, obviously it's difficult to read. Do you have any tips for how we can write more readable code when you were writing this? If you could give yourself some advice from when you were writing this, like what would you tell yourself to help you avoid this kind of a mess?
The biggest thing is testing. To be honest, I think that if this was written with tests, it wouldn't look anything like this, because the nice thing about writing tests and writing them first, at least, is you don't end up writing a lot of extra code. Like we just have a lot of duplication here. We have an extra space at the end. I don't know why we have that. It just doesn't look, it looks overly complicated. It's like there's a lot of duplication I'm seeing. I'm seeing a lot of extra comments. If these little bits of code here were all extracted in, like this is called save expand, this comment says save expansion each player. I assume it's supposed to say for each player, right? If this was just a method called save expansion for each player on our scraper, we wouldn't need that comment and we wouldn't have to look at this code, right? It would just, it's pretty clear what that's doing. And so it's almost like we kind of knew, but didn't know. All these comments here that we're like breaking up and stuff. If we take these chunks, right? If we take these chunks and extract them to a small method, and that also lets us test it, right? We could write a test for this block of code and all the different weird names that might come up and test that we're getting the right result. So I would say, once we've created that service object, like you said, and we've pulled these out into their own methods and started testing them, I think it would clean up quite a bit.
Something that I recommend people do is write pseudocode in steps. Another way that I think about this is like write the code you wish you could write to make the thing work. I definitely agree with the writing tests first. I love writing tests first. But in order to even know like what to test, right? You have to, part of what makes writing tests first so valuable is that it helps you define your API of what objects you have, how they interact with each other. But in order to know what objects you want to build, to know which ones and how they should interact, the thing I like to do is just kind of write pseudocode of, I wish that there was an object that would just do this job for me, and write the thing that it's doing in a descriptive way so that the end result of the code in the class that I'm working on is very readable. It's almost as if instead of comments, I just have methods that have descriptive names that do all the steps. And then I go implement all the steps individually later. And that's when I start to like write my test for each step, and you can isolate each one. So it's hard. And it's easy to fall into the trap of just like doing things bit by bit and seeing how they work and keep on going. But it's really, in the long run, it's just like so much better if you kind of take that approach of try to break things up into little chunks like you were doing, and then give those chunks names and call those things. Even if you don't think you need to break something out into a method to abstract it to reuse it, just breaking some weird cryptic string manipulation into a method and giving it a name, that name makes the code much more readable to future you.
I mean, if it was just this, right? Like, we just take all the players on the team.
Mm-hmm.
You know, whatever that is, and then we just return like the players. It's like
that could be your whole method.
And you don't need to look at all this garbage. Yeah, it could all just be like wrapped up into its own thing. I mean, it's just so much easier to read, and it just makes such a big difference. This took me a
long time to get into myself. So like, you just invented a model called code, right? And I guess that means like the actual text expander code, right? So that's it's an object that represents the text expander code. Now, in the real world, like it's really easy for people doing like OOP, like object-oriented programming, to think about like, let me model a user or a person or a place or a team or a league, because those are all real things. But like the idea that there's a model that represents your text expander code, like it's not a physical thing in the real world, so it might not be as obvious. Or like, sometimes there are things like business processes that you can model them, but you might not, know exactly. So by just making the jump and making a model, now you can say, okay, this object's responsibility is given a player to generate text for the text expander. And now the job of this controller, because you're in the team, or sorry, the teams, you're in the team's model. The job of this model is to represent the team, right? So now there's a method on the team that says code, and it's not the team's job to generate code. It's the code generator's job to generate the code. It's the team's job to say, go get me the code.
Yep.
Oh. So, okay, so you've kind of refactored it. You got code.new, you pass in the name, the position, and the number, and then you could generate all the text from that.
Yeah. Yep.
Yeah. So I think that's like a pretty good look at the app. We've spent almost 2 hours on this. I really appreciate your time. I think this has been really awesome. Thanks for answering all my questions and diving in deep. Is there anything that you want to share, before we wrap up? Any last words, about, either advice for people on their journey, things that they should check out, resources, inspiration, etc. Before we go off the air?
I can most recently I can recommend this book to anybody who has any even remote interest in databases. I am really enjoying it. Designing Data Intensive Applications. It goes into telling you how they actually work, and it's pretty cool. It helps explain why you might not want to use Postgres for everything, or if you're having a specific issue, this is a good reference for finding a database that might work better. So that's the most recent thing. As far as big picture, I would say just creating small hobby projects it has been the best way to learn for me, and I definitely recommend that.
Yeah, I'd also recommend, just like Chris did today, go take a look at some of your older projects. Look at what you were doing in the past if you've been doing this for a little while, and see what you can improve. If there are things that you don't understand, you can always ask for help. Get somebody to like look at it with you. I learned some things even today just talking to Chris about this. So there's always more room for improvement, room for discovering new ways to do things. Again, thank you so much, Chris. This was really awesome. Thanks for sharing your project, letting us take it apart. It's not that easy to go on live and just share 10-year-old code, but I think it was pretty fun. So yeah, thank you so much for your time, and we look forward to having you back again sometime in the future.
Yeah, of course. Thank you.
All right. Thanks.
Hello, everyone. I hope you enjoyed that. Thank you again to Chris for that amazing stream, and thank you for John for hosting the show and driving us through that. So this is the end of our stream this week. What can you expect next week? Let me give you a little bit of a spoiler to end the week. We are not streaming over the weekend. We will be back on Monday for the 4 p.m. Indian Standard Time show. We'll have possibly 3 shows again on Monday. Our main show on Monday is our guest show on this time slot. So that's the 10 p.m. European time, 4 p.m. Eastern US time slot. We'll be joined by Ethan Arrowwood, a Microsoft engineer out on the West Coast, and a maintainer of Fastify.js. That'll be Monday. Tuesday is the Dev2 takeover. That's when Nick Taylor and the rest of the team from Dev2 take over this channel. We will be joined by, I believe next week, the topic is design. So we will be joined on Tuesday at the 4 p.m. European time slot, 10 a.m. Eastern, East Coast US slot. We will be talking to Nick, and they've got Nick's special guest is Arit. And yeah, I believe they're talking about design. I think that's correct. On Tuesday. Wednesday is Accidental Twilio Day, where in the morning we have Layla Porter, and in the evening we have Lizzie Siegel, and in between it's me and Wilhelm hanging out. And then Thursday we've got Juan Pablo Flores from GitHub, the education team, and Gregor Martinez from a whole bunch of JavaScript things. And Friday, Frida Casas, who is a Raise Dev alum. So that'd be a great one for hearing more about kind of transitioning into a new career, going through Raise Dev, how Raise Dev can help, that kind of thing. So that's the preview of our schedule for next week. That full schedule will be available at the link below over the weekend. If you have any questions or things we can help you with at Oktoberfest, we are here for the whole of the month, every day up until the end of October, which I believe is 3 more weeks. It's a really weirdly shaped month. So if you have any questions that we can help you with, you can submit those to us. You're always welcome to rock up in the chat and ask questions, just like Side MT did. Thank you so much for that, Side MT. I hope that was useful. But you can also submit them in advance to the Raise.dev Hacktoberfest site down below. When you submit them in advance, we review those questions, find a guest who can best help you, and get those questions to that guest, answer them here on the show, and we let you know when they're going to be answered. And if you can't join us live, we send you the recording after. If you go to our Twitch profile, to the videos page, there is a highlight that covers how to submit a question in more detail, so you can find that right there. So final thing for me to say, what is Raise.dev? Why are we doing this? Why are we doing this show every day in October? Why do we care this much about Hacktoberfest? Well, Hacktoberfest is a fantastic opportunity to get your first steps in open source, and that's something we care passionately about. We're all about helping you level up your developer career, whether you're trying to get your first developer job, your second developer job, a promotion, a career change, you're trying to make the transition from mid-level to senior, all of those things. We are here to help you get the experience you need to make that jump, and we do that through expert coaches who match up with you, help you set your goals, and work with you towards those goals. Right now, when you sign up to Raise.dev, whilst we're in early access, we are completely free, so you can get matched with a coach and have a great kickoff call. One thing to note, when you sign up for Raise.dev at the moment, you will be told you're on the wait list. This is a genuine wait list. This isn't any of that, like, first 1,000 people on the app, the rest of you can wait until we're released nonsense. We are matching people with coaches, but this is a real one-on-one chat with an expert developer, and that takes a little bit of time to get you matched up with the amount of people we have on right now. We're adding new coaches all the time. We had a bunch join on Monday, and they're all super awesome. There's one of them who is going to help us on the show at some point. Very good camera setup, just like Chris. So they're all super great, and we're excited to get you matched up with them. But that does take a little bit of time because we've got so many people looking to get through the program. So do not worry if you see that message. That is not a quiet telling you to go away. I've had a lot of people come on the Twitch chat saying like, "Oh no, I missed the opportunity." You haven't at all. Don't worry, you're fine. But you can sign up at Raise.dev to get matched with your coach. So that is everything from me. Have a wonderful weekend. If you join us on the show next week, we look forward to seeing you then. Otherwise, I'm sure we'll see you at some point. Enjoy that weekend. Relax. Write some code, as Chris said. Work on some side projects and some hobbies. And we'll catch you at the next one. Bye.